This video shows how to create a beam-beam joint with angle brackets in the structure seen in video 10, which discussed importing a FEM model into CSE and searching for J-nodes. J-node AC, which we will consider here, is hierarchic and does not contain attachments. Let's look at the re-node associated with J-node AC, which is the only one currently selected. The J-node occurs several times in the structure, but we only need to build and check one of its associated re-nodes. Initially, only the members are present, and since the FEM model has no axial offset defined for the secondary beam, this overlaps the main one. The secondary beam does, though, have an offset that brings its upper edge to the same height as the main beam. In the previous videos, we saw how to build a node manually the way we want it. We will now look at how to apply a predefined node from the archive and modify its parameters. Only the parametric nodes compatible with the current node are shown. We select the third to last node, which involves an angle bracket connection with the same offset as the secondary beam. We will come back to this dialog box later to modify some of the parameters for this connection in real time. For now, we apply it as is. The system warns us about a member of the current node being shifted, as CSE considers the additional moments of transport. Since the offset was already there in the FEM model, the shifts in the node are null and the message is irrelevant, as the offset had already been taken into account in solving the FEM model. Now the connection is finished. We check the connection for consistency and for overlaps. There are no overlaps. The chains are listed, that is, the possible paths from a slave member to the master member. All the entities are therefore correctly connected. We set up the checks without going into the details. This dialog box is used to choose, among the other options, the reference standard, the safety factors, the methods of computing the internal forces, the checks to run, and the check on the component shifts. We select Eurocode. And we set the checking combinations as those from the imported FEM model. Now we run the checks. The listing showing the results of the checks, if requested in the settings, is shown automatically, and now the post-processing is available. We can display the utilization envelope for all the nodes' different combinations and instances. The utilization are not very high. We will not discuss the other tools for analyzing the results here in detail, as they are covered in other lessons. What we will do is reapply the predefined node with changes to some of its parameters and see how this will affect the results. We reset the node and reapply the same predefined node that we used before. In the list of operations, we untick the addition of bolt layout B1. We can thus amend its parameters during automatic construction. The construction process pauses at the point of adding the bolt layout, and we can, for example, replace the parametric formula that optimizes the computation of the number of columns with the number 1, forcing B1 to have a single column. We save the change without looking at the parameter settings in detail, as they are covered in our lessons. The node now reflects the modifications that we have made. Since the other bolt layouts were parameterized as a function of the first one, they too now have just a single column. We run the checks again, and show the envelope. With fewer bolts, the utilization are now higher.